Morning to one and all. Today we will discuss the topic total station and GPS. So total station and GPS is advanced modern techniques. So this is the first unit of advanced modern techniques. So first one is explain of the GPS. So what is meant by GPS? GPS is the global position system. It's a system used for determination of position of a object, which may be stationary or moving. The GPS is a space-based all-weather radio navigation system that provides time, position, and velocity of the object accurately with the quick period inexperienced manner. This GPS is based accurate empirical data on the real-time location of the each satellite and the previously kept. So GPS may be related certain coordinate systems such as. So first one is point position, second one is the relative position, third one is static position, next one is dynamic position. So the point position means GPS is related to well-defined coordinate system. So that is called a point position. So next one is relative position. It is a some other points as a origin of local coordinate system. So static position system means object positioned in stationary. It is used for surveying. So kinematic position means object is moving. This is adopted in navigation. So this is for basic concept of GPS. So next one is segment of GPS. So segment of GPS is comprised with the three segments. So first one is space segment or satellite consultation, and the second one is operational control segment or ground control or monitoring network. So third one is user equipment segment or user receiving equipment. So that is a 6 planes and 55-degree inclination. So there is a space segment is a totally 24 satellite is consists of the total GPS. So first topic is space segment. So space segment means it contains a satellite at orbit which provides a ranging signal and data messages to the user equipment. So there is a continuous global positioning capabilities, at least four satellites which are electronically visible or always recorded. So the consultation of satellite consultation consists of 24 satellite positioning in 6 Earth-centered and orbital planes with 4 satellites in each plane. So normally, that means sidereal data of 11 hours 58 minutes. So next, spaced about equator at 60-degree separation with an inclination relative to the equator of the nominally 55 degree to the distance from the center of the mass of the earth of a satellite. So this is known as orbit radius. That is about 26,600 kilometers. The satellite consultation provides 24 hours global navigation and time determination capacity. Satellite speed about 3.9 kilometers per second within sidereal time of 11 hours 58 minutes. It contains named orbital planes named as A, B, C, T, E, F, and the satellite within planes are assigned in the number of 1, 2, 3, 4. So this is a PRN generator or kept which is unique configured to the each satellite. PRN means pseudo random code. So this is the angular position of each satellite within the orbit. So next one is operational control segment. This is maintenance satellite and it is proper functioning will be carried out by the operational segment. So this segment is track all the satellite and they are operating properly, commonly the position in this space. So it's three different physical components of the operational control segment. First one is the master control station, MCS, and the second one is monitor stations, MS, and the third one is ground antenna, GA. This is the components of operation control segment. And first one is master control segment means it is responsible for overall monitoring and transmission sites. So second one is monitor stations. So monitor stations, pseudo range and delta range measurements. It is each monitor station checks the exact altitude and the position of the speed, overall health, orbiting satellites, all to be covered to the monitoring station. So monitoring stations made using two L band frequencies. First one L1, second one L2. So L1 is 1575.542 about 19 kilo centimeter wavelength in C by and P code. L2 is 1227.6 megahertz about 24 centimeter wavelength in P code. So this is the monitoring system. Third one is ground antenna. Ground antenna monitor and track the satellite from the horizon to horizon. There are also transmit correction information to individual satellite. Next one is user equipment segment. User equipment segment is received to the used to receive the GPS signal, which can be used for navigation and other purposes. The basic components of GPS is aware antenna, pre-amplifier, uh, radio frequency, microprocessor, control and display unit, recording device, power supply. So this is the user equipment segment. Next one is orbit determination. So orbit determination means is the process of to estimate the position and the velocity at the satellite. The specific approach based on models of the force acting on the satellite. Integration of satellite orbit motion equations measurement to the satellite. So first one is preliminary orbit determination. Second one is previous orbit determination. Third one simplified orbit determination. So first one preliminary orbit determination means it is used for geometrical method to estimate the orbit element. This is also called Laplacian or Gaussian type of methods or analytical orbit determination methods. So a Gaussian orbit determination is designed to determining the orbit parameter from the three set of widely spaced direction observation from the two positions. So it accuracy varies from 10 meter to 1000 meter. So second one is precise orbit determination. It is used for dynamic or combined geometrical or and dynamic methods. Two procedures adopted for the orbit determination. And first one is the orbit integration. Second one is orbit improvement. So orbit determination means yield of nominal orbit trajectory. And orbit improvement means it is estimate the approach state with all measurements collected from the overall data. So simplified orbit determination is developed method uses of pure geometric and pure dynamic method. This method is used to two consecutive approach or two line element obtained over the period to create the navigation solutions. So next one is orbit representation. So orbit representation is semi-major axis, eccentricity, inclination, longitude of ascending node, angle of G, and mean of anomaly. So this is the orbit components. Another three basic step processes followed by the orbit representations. So first one is offline orbit determination, second one is online daily methods, and the third one is empirics derived from the extra floating the estimator. So next topic is type of GPS receiver. So receivers. So type of GPS receiver is there are receivers can be classified into many ways. So first one is two basic type of GPS receivers or code. First one is code based receivers. Second one is carrier based receivers. So the type of further can be subdivided as first one is C by A code receivers. Second one is P code receivers. So third one is codeless receivers. Single and dual frequency receivers. Receivers using cross corrections or securing, squaring or P2W techniques. This is the based on the classifying the GPS receivers. So code-based receivers means also called as code-based receivers. There are also called as code correlating receivers since they need access to the satellite navigation message of the PRC by a code signal of operations. So next one is carrier-based receivers. So carrier-based receiver, it is used for calculating position. So Two general type of receivers are, first one is single frequency, second one is dual frequency. So single frequency receiver means track L1 frequency signal only. So next one is cheaper than dual frequency receiver compared to the dual frequency receiver, and then used to effectively to relative positioning mode for accurate baselines of less than 50 kilometer or where ionospheric effects can be generally be ignored. So second one is dual frequency receiver. Dual frequency receiver means dual means double. Okay, so track both L1 and the L2 frequency signals. It is more expansive than compared to the signal single frequency receiver, and then resolves longer baselines of the more than 50 kilometer where ionospheric effects have to have a larger impact. So eliminating almost all ionospheric effects by combining L1 and L2 operations. So that is next one is a comparison of single and double frequency receivers. So single and double frequency receivers comparison. So single frequency receivers access to L1 only. So double frequency receiver access to L1 and L2. So single frequency receiver mostly used for civilian users. So double frequency user mostly used for military purpose. Single frequency is very cheaper, and double frequency is very expensive. Single frequency is modulated with a C by E and P code. It is may not possible for civilian users once Y code is there. So that is a double frequency. So corrupted by ionospheric delay for single frequency, almost independent of ionospheric delay is double frequency. So next one is it is used for short baselines for a single frequency. Double frequency is used for both long and short baselines. Single frequency is most receivers are coded. So double frequency is most receivers with the dual frequency are codeless. So that is a comparison of single and double frequency receivers. So next one is characteristics of codeless receivers. So first point is use signal without knowledge of codes, which has advantage that the system independent of possible restriction on code access to the civilian users. Next one is empiricism nor knock and precise time can be extracted from the signals. So nowadays, totally codeless receivers are not built as the it is almost a certain C by A code will be available to all users. That is, however, for access of L2 in times of P code um, journal. So next one is other classification of receivers. So first one is based on data type use. Second one is based on technical relaxation of the channels. Third one is receiver based on user community and application. So first one is based on data type. So data means coding. Okay. So C by A code or C by A code and plus L1 carrier phase. So next one is C by A code plus L1 carrier phase plus L2 carrier phase. Next one is C by A code plus P code plus L1 carrier phase and L2 carrier phase. So next one is based on technical relaxations of the channels. So first one is multi-channel reservoirs, and second one is sequential reservoirs, multi-plexing reservoirs, all in view receives, integrated GPS receivers. So next one is receiver based on user community application. So that is the application used for the purpose of the classification used for the classification of the reservoirs. So next one is geodetic receivers. So geodetic receiver means it is used for geodetic or surveying application with the following characteristics. So first one is carrier-based data was observable. Second one is availability of both frequency. That means L1 and L2. Next one is access to P code, at least for larger distance and in geographical relation with a strong ionospheric distance. That means low and high latitude. So next one is other useful features for the geodetic reservoirs. So this is modern GPS reservoir system should be measured accurately and reliable anywhere under any condition. It is used for almost any application, geodetic, geodynamic, detailed images, and topographic engineering survey, etc. So this means geographical information system. So this is for the other useful features of the geodetic receivers. So geodetic receivers essentially receivers a requirement for geodetic or surveying applications. So first one, Liziga model. Second one is Topcon. Third one is Trimple. And fourth one is Sophia. So Liziga model is CS2O, SR 530, GPS 1200. Topcon model is Hyper. And next one is Trimple. Trimple 4600, 5700, 5800, or 8. So next one is Sophia model. Sophia model is Stratus, GSR 2650, Radian IS. So this is the geodetic receivers. So this is WP 5141 XW107. This transmit the RS232 modulus RDU, and this is transmitted to the GPS 721 MRTU. So this is the components of the receivers. So this satellite receive the signals to the GPS receiver. So GPS 721 MRTU transmit the RS 485 Volpus RTU. So this is for the PC. So PC means personal computer. So computers receive all signals and all information, collect the information and receive to transmit the information, sir. So next one is considering the selection of GPS receivers. So first one is technical consideration, field suitability, combining software, data logging, business consideration, receiver operations. So first one, technical consideration. Technical consideration means a type of data collection. So measurements, which various type of measurements are collected, and the single and dual frequency method used to collect L2 carrier, sequence of parallel channels, number of channels, antenna type and noise characteristics, accuracy of code and or carrier measurements. So this is the technical consideration. Next one is field capacity. So field capacity and suitability. So weight, size, uh, roughness, and operating temperature, power requirement. This is the field suitability. So next one is accompanying software, satellite protection, downloading capability, post processing options. So this is the accompanying software. Next one is data logging. Data logging means the data storage, data final product store, um, how to prepare the data collecting and data rates, storage method, data storage capacity, downloading method, type of data which is downloaded. So this is the data logging. And then business consideration. Business consideration is warranty, cost, technical support. This is main factors for the business considerations. So next one is receiver operations. So receiver operation means it is access to easy of users, intended applications. It's the ability to monitor tracking status. It's easy of entering station numbers. So this is the consideration of the selection of GPS receivers. So next one is components of GPS receivers. So first one is antenna with the pre-amplifier. Next one is radio frequency. Next one is intermediate frequency, front end section. Next one is signal tractor and code correlator section, reference oscillator, microprocessor, navigational solution units, other parts, memory, power supply, display, and control. This is the components of GPS receivers. So next one is this is the antenna and the preamplifier, transmit the signal processor, coding tracking loops, interconnected carrier tracking loop. This is transmit the microprocessor navigation solution, and then transmit command and display unit. This is transmit transmit memory, and the preset oscillator is transmit the signal processor box, and then finally the external data is logger. So this is the components of the GPS receivers. So next one is the next topic is main topic is total station. So total station is nowadays mostly used for many constructions. So electronic digital was first introduced in the late of 1960 by Carl Jesus in that. The instrument has helped to set up the status of modern data collection and processing. So the total station or electronic tachometric is a combination of electronic theolite, EDM, microprocessor. So EDM means electronic distance measuring device with the memory unit. With this device, one can be determined angles, distance from the instrument to the points of the survey, which is application of the trigonometrical angles. Distance may be used for compute the actual position of the surveyed position of the absolute terms. So the basic principle of total station. So total station is very accurate measurements of the surveying. So the standard of transit electronic theolet is basically telescope with a crosshair for sighting of a target. This is relatively to north is 0 degree angle of inclination of the telescope. And then electronic distance measuring transmit infrared beam, which is reflected back to the unit, the help of the prism. So EDM applies timing measurements to calculate the distance traveled by the beam. The main requirements for the EDM measurements, the telescope reflective, which is usually achieved by the uses of reflective prism. So next one is the microprocessor. So microprocessor included the total station is used for reduction of observed data. So next one is electronic theolite. So electronic theolite, nowadays most manufacturing produce electronic theolite covering the range of offered by the optical equivalent, but is least cost, less cost. So electronic theolite displays horizontal and vertical angles of 0.1 seconds with a standard division of 0.5 seconds. The common features provided in the theolite caters for tilting, uh, tilting of vertical axis. Next one is electromagnetic distance measurement. So EDM. So accurate measurements of the most difficult of surveying operations. The introduction of electromagnetic distance measurement has completely removed this difficulty. The revolution of can measure the distance on accuracy of the few millimeter to press the button, and then it is two group of EDM instrument can be identified, namely electronic or microwave types. So electro-optical types and then electro-optical types. So that is in case of velocity of the electromagnetic waves is known as precisely accurate determination of the distance. First one is microwave EDM system. So microwave EDM system is the important position of the land surveying because they are used to measure the distance varying from 50 meter to 50 kilometer. The introduction of GPS has been dimensions at the bottom. So this is consists of master. It's set to set up at a one end of the distance to other end. The remote is established at the other end. So next one is electro-optical EDM measurements. So electro-optical EDM instruments are mostly by civil engineers, used by civil engineers. The measuring length varying from 1 kilometer to 60 kilometer. As with the microwave instrument, all need of the line of sight conditions. The main components of instrument this group are light source, visible light produced by the tungsten lamp, xenon glass tube, and or laser light or infrared light. A light modular, optical parts for transmitting and using the modulate lighter. So next one is the calculation of EDM system measures the scope distance S along the carrier wave. If the instrument display the horizontal distance H, it is because it has measured the vertical angles theta and to be performed the calculations. So H equal to S sin cos theta. So in similar manner, vertical difference in elevation B comes from the calculation V equal to S sin theta. So this is the electro-optical EDM system. Next one is EDM principle. So EDM principle, basically there are two methods followed by the EDM principle. First one is pulse method. Second one is phase difference method, which is employed for the distance measurement. All the equipment are based on the principle that the distance d is equal to product of velocity and the time t. So this is the EDM principle. So first one is pulse method. So pulse method is based on the simple concept of distance is a product of velocity and the time. So there's a static diagram of one end is emitter, one end is receiver. So transmit the signal, pulse phase. So reflector is collecting the information signals. So revise transmit the reflector target. So a short but intensive pulse of radiation is transmitted to the reflector target, which is transmitted back to the receivers along with the parallel path. The measured distance is got from the product of velocity of the signal and complete the time taken to the travel. So that means that 2D equal to C into delta T divided by delta T. So D equal to C into delta T divided by 2. So that means that delta T means TP minus TA. So TA means time of departure of the pulse from gateway. TP means time of reception at gate B. So that is difference between the delta T. So C is the velocity of light in the medium so which is traveled. So D is distance between instrument and the target. So that is called a pulse method. So next one is phase difference method. Phase difference method is speed of light is vacuum is Vernon and the measurements is taken not in the vacuum. So the correction for the atmospheric condition have to be more. Further, because of greater speed is not possible directly and previously measured to the time taken to the travel. So EDM instrument measure the phase difference between transmitted and received signals. So next one is different wavelengths are used to determine the distance. The form of basis for the pulse difference method. So majority of EDM instruments were the infrared or microwave adopting the form of measurement. The principle of EDM is presented by the basic equation of the system is component. So M is integer part of wavelength, delta lambda is fraction of the part of the wavelength, pi divided by 2 pi into lambda. So lambda means wavelength, pi means phase difference. So that is called a phase difference method. So the main topic is features of association. So features of association combines on electronic theorem with a distance measuring system and a microprocessor. So that is the association. So next one is parts of association. Different parts of association. First one is telescope, plate level, keyboard and a display, and then window, dry patch, vertical tangent screw, power switch, vertical motion clamp, horizontal screw, so horizontal motion clamp. So all of the parts of the association. Next one, angular measurements, distance measurements, and slope distance. So first one is angle measurements. So all the component of electronic unit are found in association. The axis of the configuration is identified and comparisons with the vertical axis, pointing axis, and the line of sight. So other components include tripod with the lever input screw, keyboard with the display, and the telescope which is mounted on the standard, and which rotation around the tilting axis. So next one is distance measurement. So distance measurements. So distance measurements, which is measurements of the slope distance, which is onboard computer used together with the genic angle recorded by the line of sight, also the horizontal distance. So next one is keyboard and the display. So total is activated through the control panel, which is consists of keyboard and multiple line LCD. A number of instruments have to be two control panels. So one each phase, which makes the easier to use. So next one is software application. So the microprocessor built into total station is a small computer and is main function of the controlling the measurement angles and the distance. So LCD screen guides the operator taking the measurements. So the software application available in many total station include the following. So first one, slope correction and reduced levels. Second one, horizontal circle orientation. Third one, coordination system, measurements and the measurements, traverse measurements, resection, remote elevation measurements, areas, and setting outs. So this is the software application. So next, total station advantage and disadvantage. So advantages of total station for the following. First one is setting up instrument quickly on tripod using laser cluster and onboard area commutation program to commute the area of the field. And for a quick visualization, graphical view of the plots are available. Integration of database and old maps are automatically done. So next one is disadvantage of total station. Hard copies of field notes are not provided, and then cost is equipment is very high. Cost of the equipment is very high, and skilled labor person is can use the instrument. It cannot be used for routinely the operation of the sun unless the physical filter are used. So this is the disadvantage of the total station. So so overall, the section is covered by the covered for the total station and the GPS instruments. So this is hand held GPS Lesiga model. So this is a one hand use of or a down and enter dumpy key, contest menu key in main menu contrast, escape or enter buttons. So RS 232 and the external antenna. So this is how to use of how does GPS work? More satellite is received to the signals and transferred to the information. So collecting information of hand-held GPS reservoirs. So this section cover to total station and GPS component spots, advantage and disadvantage, applications. So all are covered. Thank you.